To prepare a pesticide spray, 2.5 pounds of biocid is added to 24 gallons of water. How much biocid should be added to a spray tank holding 340 gallons? Okay, so again, the key to doing one of these proportion problems, with proportions are just comparing two ratios, is to make sure that the units match on the top and the bottom. So let's see, the first one is saying for every 2.5 pounds of biocid, you have 24 gallons water. Okay. Now I put more information in there that was necessary. I'm just trying to make it really obvious where the numbers go, where the units go. So since on the first one I put biocid on the top, it says how much how much biocid should be added. Well, that means you don't know this one. You know it's going to be in pounds, and you know it's going to be biocid, oops, but you don't know the amount. Okay, now what about the bottom? It says holding 340 gallons. Okay, the gallons are going to go on the bottom, and we also know that's water. Okay, so again, all the thorough labeling is just to indicate biocid on top, water on the bottom. You could flip it, by the way. With cross multiplication, it works either way. You could have just as easily put water on top and biocids on the bottom. I just do it the order that it's written, but you don't have to do it that way. Okay, now I'm going to rewrite the problem, but instead, I'm just going to leave off the units this time. Okay, and you can put as much as you want. You can put pounds on top, gallons on the bottom. You can leave out the biocid and water. You can label it as thoroughly or as little as you need to, just as long as you put everything in the right position. Okay, so now we're going to cross multiply. So we're going to say 24 times x equals, and 2.5 multiplied by 340 is equal to 850. All right, so at this point I'm going to divide both sides by 24. And that gives me x is equal to 35.416, and that just repeats. And let's say we wanted to round it to the hundredths place. All right, so that'd be 35.4, and then since the 6 is 5 or higher, you'd round the 1 up to a 2. And so we could say, well, x is approximately that right there. The ideal air to fuel ratio for an engine is 15.2 to 1. If a vehicle burns 7 pounds of fuel, how many pounds of air should it draw to achieve the ideal ratio? Okay, so we have a ratio of 15.2 to 1. And I'm going to label this, it says air to fuel ratio. So the top is going to be air, and the bottom is going to be fuel, and that's equal to, and now it said 7 pounds. Okay, well, we'll assume that the fuel is in terms of pounds, right? And the air is the question over here, so we're going to put 7 pounds on the bottom. So it's 7 pounds of fuel. Probably should have put pounds fuel. And the question is, well, how much air, right? How many pounds of air? Okay. So again, how many pounds of air? That's the question. Okay. So now we don't really need the units. I just need the units to point out that we're putting air on top and we're putting fuel on the bottom, right? Okay. So at this point we have 15.2 over 1 is equal to x, an unknown amount, over 7. Okay, so we're going to cross multiply, which means we just end up with x is equal to, and we say 15.2 times 7, which gives me 106.4. Next, we have a landscape architect is seeding a 7,200 square foot lawn. The seed manufacturer recommends using 4 pounds of seed per 1,200 square feet. So, and the question is, how many pounds of seed will be needed? Okay, now in this point, we have a ratio between 4 pounds of seed, and again, I'm over-labeling everything, just trying to make sure it's clear where these numbers go, to 1,200 square feet, and of course that's lawn. You need to put that there if you want lawn. Lawn. Okay, now they give us 7,200 square foot lawn. Okay, now where are we going to put that? Well, since I put the 1,200 square feet While on the bottom, I'm going to put the 7,200 square feet on the bottom. And you can even label it long. You don't really have to do that, though. Okay, and the question is, how many pounds of seed do they need? X pounds of seed. Again, I'm just labeling everything to make sure it's obvious how everything matches. So I put seed on the top, seed on the top, lawn on the bottom, square foot of lawn on the bottom. Okay, fair enough. Okay, so I'm going to remove those. Don't really need those units anymore right now. You can leave just the units if you want to, but we have 7,200. Okay, so now we cross multiply, so we end up with 1,200x, and then we say 4 times 7,200, and that gives me 28,800. Okay, then we undo the multiplication of x by 1,200 by dividing by 1,200. Whatever I do to one side, I do to the other. Those cancel out over here, and you end up with x is equal to 24, which means we have 24 pounds of seeds. Excellent. Okay, we have a 12-inch wide conveyor, and it unloads 2,000 bushels of wheat per hour. At this speed, how many bushels per hour? How many bushels per hour will an 18-inch wide conveyor unload? Okay, so first one we have 12-inch. You can even put conveyor in there if you want to. Just really trying to make sure we match on the top and the bottom. And that's over the 2,000 bushels. And you can even put per hour if you want to. It's going to look a little different if you do that, though. Okay, now it says how many bushels per hour will an 18-inch conveyor use? So we have unknown number of inches for the new conveyor, right? And again, I'm over-labeling everything, just making sure it's really obvious where everything goes, right? Again, we have the inches of the conveyor on top, we have the inches of the conveyor on the bottom, we have the bushels on the bottom, and then we have, so that backwards. All right. So we have the 18-inch conveyor here, and then we have the unknown number of bushels on the bottom. The unknown number of bushels on the bottom. Okay. So at this point, we've set everything up correctly. So we have 12 over 2,000 is equal to 18 over x. We do cross multiplication. 12 times x is 12x. And we have 2,000 times 18, which is 36,000. And then we say 36,000, 12x divided by 12, those cancel out, leave me x. And 36,000 divided by 12 will give me 3,000. So it looks like the answer to this one is going to be 3,000. Okay. So the 18-inch wide conveyor will unload 3,000 bushels per hour. Technically, just realize that normally if you give it a word problem, you answer it in sentence form. Technically, you want to do that just for clarity, but I mean, x equal to 3,000 is fine. But again, it's not a bad idea to answer it in sentence form. So the answer to how many bushels per hour would be the 18-inch wide conveyor will unload 3,000 bushels per hour. Something like that, right? Okay, the dosage of certain medications are based on a patient's body surface area as measured in square meters. Suppose a physician prescribes a daily dosage of 2,600 milligrams per square meter of medication D for a patient. If the patient has a BCA of body surface area of 1.53 square meters, how many 60 milligram capsules should the patient take per day? Okay, so what we're basically doing is we're trying to somehow convert from 1.53 square meters, okay? We're trying to convert that to the number of capsules. Well, we do have square meters here. Let me kind of choose a different color. Okay, so we have square meters here, and we have square meters here. So we can connect those two, right? And then from there, we have milligrams here and milligrams here. And then for finally what we actually want in this case, we want capsules. Okay, now the reason I did that is I'm just trying to show you how you're going to work through the problem, right? So I'm going to go from square meters to milligrams, right? Square meters right here to square meters right here, right? And that's going to get me to milligrams because the square meters is connected to milligrams. The 260 milligrams is connected to square meters. So I'm going to put the 260 milligrams on the top. and I'm going to put the 1 square meter on the bottom. Okay, so that's how I'm going to do that one. Now from there, I want to go from milligrams to capsules. Okay, so I'm leaving or getting rid of these 60 milligrams, but I want to end up with the capsule. The capsule. Okay. Now what happens is these units cancel out. I know I'm doing this kind of in an advanced way, but this scales really nicely. And the milligram cancels out here, leaving me capsule. So I probably set it up correctly. And what I can do here is I can multiply everything through and I'll get 6.63, which is approximately, because you're not going to give somebody 63 hundredths of a capsule, you'll give them 7 capsules, right? So capsules, capsules. Now you can come to the same conclusion one step at a time. This is all together. So you could say, for instance, well, I know I have 1.53 square meters, and I know that for every square meters I get 260 milligrams. So I'm going to multiply those together, and this will give me the number of milligrams, which would be 397.8. Okay, but now I'm at milligrams, right? So this started off at square meters, and this right here started off with milligrams, right? And then from there, well, okay, well I have 397.8 milligrams, but I know I have 60 milligram capsules, so I have to divide this by the 60 milligrams, right? The 60 milligrams, and that would be the number of capsules, right? This is if you want to do it step by step like this. You don't want to do it all at once. Hopefully this logic makes sense so far. And then that will give me 6.63, and of course that is the capsule. So you can kind of just not focus so much on the units in this way. And then of course that does give you approximately 7 capsules like that. Okay, so in the long run, the first way that I showed you is probably better, just doing it all at once. And because if you keep track of the units, the unit cancellation will tell you whether you set it up correctly, and then your final answer, whatever that unit is, that will tell you that you got the correct answer. Whereas the second way, if you just do one step at a time, it gets rather confusing whether you multiply or divide, and whether you set it up correctly. But it does work, so if you're more comfortable just doing one little step at a time, you can do it the second way over here.